Hello, welcome to Mathis, my tutorial channel. Today in my last video I talked about basic derivatives, and in this one we're going to use a definition of a derivative to solve problems when we are asked to find the derivatives of functions. Now the formula here is, if you want to find the derivative of f of x, you have to set it equal to limit when h tends to 0 of f of x plus h minus f of x over h. So make sure, how do you find f of x plus h? Well, to find f of x plus h, let's say this 5x cubed is our function and we try to find the derivative of this term. How do we approach this? So we'll replace x by x plus h. So in your function, anywhere you see x, replace that by h. Replace that by x plus h, right? So in our case here, so in this problem we'll do it term by term. That way you kind of get an idea about how to do a radical function or a rational function or a regular like polynomial. So let's use this first term, 5x cubed. So I'll call this a g of x, right? So I'm trying to find g prime of x using the derivative formula definition. So that would be limits when h tends to 0 of 5 times, remember, replace x by x plus h. So that would be x plus h cubed minus f of x. Well, f of x is what? 5x cubed over what? H. Now, you can develop this to make it easier, because if you substitute the value of h here, 0 0, you go back to the same thing. So you don't really like do anything. So let's develop this and we'll see what we get. So that would be equal to, don't forget to rewrite the limits of, so x plus h cubed, that would be what? If you have a plus b, everything cubed, it's equal to a cubed plus 3a squared b plus 3a b squared plus b cubed. That's one of the remarkable identities. Or you can just set this a plus b squared times a plus b, or you can just do all this and erase that and just develop it. You'll find this same result there. All right, so I'm gonna use that here and go ahead and put it 5 times x cubed, plus 3 x squared h plus 3 x h squared plus h cubed minus 5 x cubed, right? All that over h. Now if you go again, I have, there's a parenthesis here, I have 5x cubed here, because if this 5 goes into, it will multiply these, so these two will cancel out, right? And this term will cancel out, so you only be left with 15, because remember, you have 5 times 3, so that would be 15 x squared h plus 15x h squared plus h cubed, all that over what, h. So, and here, we have h here, we have h on every term here, so we can go ahead and we have h at the bottom and h on every term at the numerator, so we can go ahead and cancel out the h. So this one will go away, this one there will be only one left, this one there will be only three left, so I mean two left, and then this one goes away. So we are left with what? Sorry, don't forget to write the limits. H tends to 0. So we'll be left with what? 15, limit when h tends to 0. We'll be left with 15x squared plus 15x h plus h squared. That's it. Now you can substitute, the value of h in, and that means if you substitute h in this one, it will be what? 15x times 0, because h tends to 0, so it will be 0. This one will be 0 too, so you'll be left with 15x squared, right? And that's exactly what we found in the previous video. So that's your first result there, and now I'll call this, let's go to the second one. The second one is pretty much the same here. The coefficient doesn't, that's just a real number, it doesn't really do anything. It's not a rational function or anything, so let's skip that. It goes to the next one. So I'll call this h, let's say I'll call that I'll call this t of x, right? That function t of x. So let's find t of x, t prime of x. That will be limit when h tends to 0 of using also this same formula. So plug in, replace every x by h, x plus h, to find the f of x plus h. So we'll go with 2 square root of x plus h minus f of x, which is 2 square root of x, right? All that over h. So we have this here. Now, when you have a radical functions like that, the best way to do it, is to multiply. You're trying to pretty much cancel these radical signs up here, right? So we'll multiply by the conjugates, by the conjugates. So we'll do this. If we multiply these by the conjugates, we'll have, let's simplify this first. That way, it will be clearer to see. So we'll factor out the 2. So we'll have x plus h. Why am I using red for everything? Minus square root of x. So we have that, right? Now we can multiply these by the conjugate. So that would be what? Square root of x plus h plus, the sign here, the opposite. and then divide. If you multiply the numerator by whatever, divide that by the same thing. So right, so you have this. So you have this, right? Now this term here basically looks like this: a um a minus b times a plus b, right? Which is equal to what? A squared plus minus b squared. So these terms will be squared, and the square root, if you square out a square root, you know, the result is what? The result cancels out the square root. So that means the numerator will be 2 times what? X plus h, because that square root goes out, minus x, basically, right? So now that we have this, we can do that over h times the square root of x plus h plus square root of x, right? So now that we have this, we know the x's are going to cancel out. X minus x is 0, and so we'll be left with 2x up here, 2h, and then here we'll have h, and same thing, square root of x, right? So, and this h will cancel out again as well, so we'll be left with 2 at the top, and then all these here. Now once you have this, you can go ahead and plug in the, replace h by 0, and you'll find the result of it. Now notice I didn't write the limit all the way, so yeah, go ahead and write those. Every time, every step, you have to write the limits. So h goes to 0, same here, limit, and h goes to 0, same here as well. Alright, so our final result will be what? Limit when h goes to 0 of what will be, we'll have 2 left at the top, and remember here we'll also have what? Square root of, we'll have the square root of x plus h plus square root of x, right? So if we solve this, if we replace h by its value here, we'll have, keep using red, we'll have 2 over, if h is 0 here, then you are left with what? Square root of h. So square root of h plus square root of h, it's 2 square root of h, square root of x, square root of x. So cancel out these two, you'll be left with 1 over square root of x. And yeah, that's what we found in the previous video, right here, right? That's the first result. It's 1 over square root. So let's go ahead and solve the following one with the one with the rational function. So I'll call that rational function um, let's say L of x, right? So you're trying to find the derivative L prime of x using the limits. So you'll be limits of L when h tends to 0 of of x. So L. So we'll have, remember, we have that formula. So the first term is what? The first term is f of x, x plus h. So we'll replace everything, everywhere we see x, and this term here, we'll replace it by x plus h. So let's go ahead and do that. So we'll have negative 3 over x plus h squared. And then remember, here we have negative sign, but our term already has a negative sign here. So negative times negative, they cancel out. It'll be positive. Sorry, I keep using the red color some reason. So we'll have only f of x, which is just x squared over h. Right? Now, if you solve this limit, you'll get the result. So let's go ahead and solve this limit. Now, we don't want to have double fraction here, that's how I call it. So we'll be trying to at least make this, the numerator, turn it into a linear function. So the way we can do this is multiply the numerators, multiply everything here by both sides basically by the common denominator of the numerator, right? So we can go ahead and write this. Goes to the limit when h goes to 0 of that negative 3 over x plus h squared plus 3 over x squared all over h, and all that times the common denominator of the numerator is x squared. So we'll do x squared times x plus h squared, right? And do that same thing up down here. So right, so now once you have that, you can go ahead and simplify everything out. So we write this limit term, and so if that multiplies the first term here, these x plus h, everything squared, would cancel out, right? So we'll be left with 3x squared, negative 3x squared. Right, now the second term, if this multiplies this, the x squared will cancel out, so we'll be left with positive 3 times x plus h squared, right? And then our denominator will be left with h x squared times x plus h squared, right? So once you have that, just go ahead. Now if you plug in the value of h, It's still not good because you'll have 0 at the bottom and you don't want that. So let's go ahead and do a little more expansion and factorization, and we'll see what we get. So that if we expand it, we'll have that goes at the bottom. We'll have what limit when h tends to 0 of negative 3x squared plus. Now we're going to expand this term here, right? So let's expand that. Would be 3. I mean, this term here, see, that term equals to what? X squared plus 2xh plus h squared, right? So that's one of the remarkable identities. So if you expand that, that's what you'll get. So we'll have 3x squared plus 6xh plus 3h squared, right? So now that we have that, and at the bottom we'll have h x squared x plus h everything squared. So now that you have that, we see that this here they cancel out. These two terms cancel out. So and then we can factor out the h, right? So we can factor out the h. So that means this h will go, and then here we'll only have one h. So and then this bottom h will go as well because they're canceling out. So at the numerator we'll have limit when h goes to 0. Change color. Of we're left with 6x plus 3h, right? And at the bottom we'll have x squared times x plus h everything squared, right? So now that we have this, what else can we do? Can we just plug in the value of h? If we plug in h here, we'll be left with x squared right here. So x squared times x squared, that's x to the 4th power, and then here will be 0. So we'll be left, we can go ahead and plug in that. So that would be 6x over x to the 4th power, and we can simplify this as well. So these x will cancel out, so we'll have the result will be 6 over x to the 3rd, right? And that's exactly what we got in our previous answer right here, right? So all right, well, that's it. That's how you use the derivative function for derivative formula to solve derivatives. So if you like this video, please subscribe to my channel. I'll be making more videos like this, and I try to make use lots of different examples that will kind of facilitate that will expose you to all types of functions that you may come across. So stay tuned for more derivatives to come, like with the sine trigonometry, like sine, cosine, all those type of functions. And also on my next videos, I'm gonna do how to find the derivative of two functions, like the product of a function or the quotient of the function. So stay tuned.